In other videos, we have talked about that the type of element that we are dealing with is defined by the number of protons in an atom's nucleus. So for example, any atom with exactly one proton in its nucleus is by definition hydrogen. Any atom with 6 protons in its nucleus is by definition carbon. Any atom with 17 protons in its nucleus is by definition chlorine. And so these numbers that I'm circling on a periodic table of elements, that's known as the atomic number, but it's really just the number of protons in an atom of that element type's nucleus. And that defines what type of element it is. But in this video, we're going to dig a little bit deeper and realize that you can still have different versions of the same element. And these versions, in chemistry speak, are known as isotopes. Now, how can you have different versions of the same element if the number of protons defines what the element is? Well, the versions, the various isotopes, are going to happen based on the number of neutrons you have. So, for example, there are 2 stable isotopes of chlorine. There's one version of chlorine known as chlorine-35. Let me write it over here. Chlorine-35. It's sometimes written like this. In fact, it's often written like this. Chlorine-35. And this isotope notation that you see over here, where we have 35 in the top left, that 35 is a sum of this version, this isotope of chlorine's protons and neutrons. This number 35 is this isotope of chlorine's mass number. So if it has a total of 35 protons and neutrons, how many neutrons does this version of chlorine have? Well, it's going to have 17 protons. 17 protons. I know that because we are dealing with chlorine. So how many neutrons will it have? Well, 35 minus 17 is 18 neutrons. And there's another version of chlorine that is stable, and that is chlorine-37. Now, how many protons is that going to have? Well, that was a trick question. By definition, it's chlorine. It's going to have 17 protons. This is going to have 17 protons. But then how many neutrons will it have? Well, the protons plus the neutrons is 37. So 17 plus 20 is going to be 37. So it is going to be 20 neutrons. And this would be written out as chlorine-37. So you can see these are 2 different versions of chlorine. Same number of protons, which make them chlorine, but different number of neutrons. Now you can imagine these different versions are going to have different atomic masses. But here on a periodic table of elements, there's only one average atomic mass listed. And the key word here is this is an average atomic mass. It's the weighted average of the masses of the chlorines, the stable chlorines that you will find. So for example, in nature, 75.77% of the chlorine found is chlorine-35, and then the remaining 24.23% of the chlorine found is chlorine-37. So when they calculate this average atomic mass, what they do is they would take, or you would take if you were calculating it, so this would be 75.77% times the atomic mass of chlorine-35 plus, and now the weight here would be 24.23% times the atomic mass of chlorine-37. And if you were to do this calculation, you would get this number right over here, 35.45 unified atomic mass units. Now, how do you figure out the atomic mass of chlorine-35? You might be tempted to say it's just 35 unified atomic mass units, and you would be close, because the mass of a proton is close to 1 universal atomic mass unit, and the mass of a neutron is close to 1 universal atomic mass unit, and then the electrons have a much smaller mass. You can also almost consider them negligible for atomic mass purposes, and so you will get an atomic mass close to 35. But it actually turns out it's a little bit different, because not only are the masses of each individual proton or neutron a little bit more, actually, than one unified atomic mass unit, but when you put all those protons and neutrons together in a nucleus, their combined masses is actually a little bit less than their individual masses if you were to just add them up, and that's actually known as a mass defect. And so if you actually want to know the atomic mass of chlorine-35, you can look that up in a lot of tables. And you will see that it's actually slightly under 35 unified atomic mass units.